Okay, so today we are talking about the quadratic formula. It helps you get the x-intercepts, and we have been practicing this on the top 20 for a while now. So here is a problem that's just like a canceling issue. Can or can't you cancel? By now, I hope you know there are some of these where you can cancel and some of these you can't. I've taught you how to factor and then cancel. See if you can tell then. Some of these can cancel, some of these can't. There's 3 questions. Simplify them all down. Some of them can't simplify because you can't cancel. The way I like to think of it is, if it is factored, then it's all primed and ready to cancel. Like, do you get that this one is really 3 times x, which makes 3 a factor, and x a factor? It's been factored already. It's a multiply problem. So I can cancel those, and it's just 3. Raise your hand if you knew that. Good, that's the easiest one. Now, everybody wants to cancel this when you first start this class, but you can't. Do you get that now? You can't cancel those because you can't. It's not part of a multiply problem. It's part of an add problem up here. So I cannot cancel those x's. And then over here, you can if you factor it. So did you get the 3 factors out? And you'd have x plus 1. And then this 12, I even like to even think of this as being factored into 3 times 4. You see what I mean? That way, this can cancel this after it got factored. Final answer, x plus 1 over 4. Raise your hand if you had that one right. Good. All right, moving on. So square root of 20, how do you simplify that? We've practiced this for so long, you should be good at this. Root 4, root 5, what's the final answer? True root 5, good. Do the other 3 of them that are on the page there. On 54, what's a good thing to split it into? Root 6, root 9. And I like to put the one that's perfect first. So, Mr. T, what do you think? Final answer?
6, or sorry, 3 root 6.
There you go, good. All right, and, yes? Are you talking about number 54? Oh, okay. 16 times 3 makes 54. Let me check that. 3 times, no, that makes 30, that makes 58. So you're close, but there are kinds like that, like 90. Do you get that they could be 45 and 2? Or I could have done 9 and 10? Or I could have done a lot of things. But as long as you do it right, you can start with anything you want. The best thing to start with is root 9 and root 10. No, it isn't. Well, okay, it might be. Let me check. This one does work, 3 root 10, but is root 10 for sure simplified all the way? Well, root 10 could break into root 5 and root 2. But root 5 and root 2 are both prime numbers, so they can't be simplified down further, so that is a good thing to start with. All right. What's root 45 and root 2 going to do for you? I was thinking that was better because I was thinking square root of 45 came out nice, but it doesn't. But if you start this way, it's not like it's wrong. I just got to go further. Root 45 breaks into root 9 and root 5. And I still have this root 2 here. And then I can say 3 root 5 root 2, and hopefully you'll go, oh, I guess I got to put those back together. 3 root 10. So my point is that you can get to the final answer no matter which way you start, as long as you keep going. All right, how do you know you're done? You're done if the square root that you have cannot be simplified any further into like a perfect square and another number. Like root 5 and root 2 doesn't make it any better. So we leave it at root 10. All right, root 32, did you get 4 root 2? Good. And then root 54, did you get root 9 and root 6, therefore 3 root 6? Okay, good.
Got root 2, I got root 8.
Okay.
For 32.
For 32, because 8 times, okay, wait a minute. what was 32 breaking into in the first place? First start with 2 square roots. You tried to skip a step, I think. 8 times 4 is 32. Okay. I get you, but you didn't. You got trapped. Yours is kind of right, but it's just not all the way right because square root of 8 can keep going. Think about it. Keep going. 4 and 2, and isn't the square root of 4 going to come out nice? Yeah. See what I mean? So you just didn't go all the way. You were right up to here. You just weren't all the way done yet. See what I'm saying? Because square root of 8 can break down further. So this becomes a 2, and this becomes a 2. 2 times 2 is 4. 4 root 2. Now, it would have been better if you'd have noticed that 16 and 2 worked right off the bat, and then it's 4 root 2. But I know you didn't notice that, so you should have just kept going. And the way you could have known you weren't done is that root 8 could break up into root 4 and root 2. And that root 4 is perfect, so you should have kept going.
So until you hit a prime number.
Yep. Until you hit, the only things it breaks into is primes. All right, so like this. If you get this far, 2 root 12. Are you done or not?
No.
No, because you could use
2 root 3.
root 3 and root 4. And then the root 4 is perfect, and therefore it's 2. 2 times 2 makes 4 root 3. Okay, so just don't stop. If you get reduced down this far, you're not reduced all the way yet. Okay, good enough on that stuff. Now here's one where it's just the plain old quadratic formula. Do you recognize that it's really the discriminant underneath there? And the other thing I want to point out is that if that discriminant comes out to 0, do you get all of this will go away? If the discriminant is 0, then adding or subtracting 0 from your other answer means nothing, right? So therefore, that is the formula for the what? For the vertex and something else. And it gives you the x, thank you, axis of symmetry. Okay, it gives you the x of your vertex, and it gives you the axis of symmetry. Because if you think about it, here's the vertex. The axis of symmetry has to run right through that. So that's why it gives you both. Okay, so this quadratic formula is built with all kinds of cool stuff. This discriminant part, you're going to be tested on that. Well, you get tested on everything, but discriminant is a piece you have to be able to do separately. Just say, what's the discriminant? And you got to go, okay, b squared minus 4ac, and you get the answer. What does this discriminant mean? Let's do one like that. That's from yesterday. Here's one. Y equals negative 2x squared minus x plus 1. What is the discriminant, and what does it tell you? By the way, a hint, it tells you how many solutions there are. Mr. A.E., tell me what the formula is. Don't need a y equals or anything. Just the little formula with the starts with b squared. Yep. So now I'm going to make it a skeleton. And now I'm going to drop in the right things. B's negative 1. I hope you didn't put an x by accident. A's, B's, and C's are numbers. And A was negative 2, and C was 1. And then I actually grind it out, and this becomes positive 1. And there's 2 negatives in this, which makes the answer become positive 8. And I put it together, and I get 9. No, 2 negatives. It happens all the time. People think 1 minus 8. Nope. There were 2 negatives. So what does that mean? I got 9. Yep. Because it came out positive, there's 2 solutions. Had it come out to, like some of you thought it was 1 minus 8, and it was negative 7. Had it come out to negative 7, we'd have said no solutions. I am spelling solutions wrong. S-O-L-N. This one has 2 solutions. And if it had come out to 0, because it had been like negative 8 plus 8 or whatever, and it came out to 0, we would say 1 solution, and it's special. The vertex. when you get only one, when you only get a 0 at the end, that one thing you have left is negative b over 2a, and it's the vertex. All right, cool. So let's see. These two are just simply like you're right off the top 20. These are things that I knew were going to be hard for you to try to do all at once, so we practiced them early. Now you should be good at it. Yes?
I have a question on the last question. When you drop like the square root, can you do like the
All right, everybody work on these two while I'm answering this question. You asked, why do you drop the square root? Because the quadratic formula includes a square root. The discriminant does not. The discriminant is the part that's under the square root. You don't actually square root the discriminant.
so in your word you don't want to have any?
Nope. If you're doing a discriminant problem, don't square root it. Today is about quadratic formula. When you do the whole quadratic formula, you definitely do want to do the square root, but that's only for the whole quadratic formula, not just the discriminant part, which is the little part underneath the root. So you notice on these three answers, I never did a square root. When these two were made up, I'm just saying, what if that had happened? Okay. On these, I'm hoping by now you're good at this kind of thing. So that's root 9 and root 3, so it's 3 root 3. So did you have negative 6, plus and minus, 3 root 3, all over 9? Good. Now tell me how to do the next part, Miss SF. Top part. All right, so on the top, take a 3 out of everything and tell me what you have left. Yep. On the bottom, we still have 9. You know what I'm saying? I'm just trying to rewrite the problem, except factored. And, oh, should I factor the 9 into 3 times 3? That might be smart, because that'll set it up for an easy cancel now. Cancel, cancel. That's what's left, and that's the answer. No, you can't simplify that further unless you happen to have a calculator and know what the square root of 3 is. If you knew the square root of 3 was like 0.127, you could actually do it once with plus 0.127 and with minus 0.127. But anyway, we don't know what the square root of 3 is. I know it's 1 point something. You can leave it just like that. All right, everybody check on the red one. You should be able to simplify that down and get an answer just like I just got there. Something will cancel. And would you please compare it with the person, you know how the groups go, straight across from you. This one's so easy it freaks people out sometimes. You're like thinking, well, this must be more complicated, but it's not. Square root of 25 is just 5. Now, can I do some more canceling? Yeah, I can. If you want to do some more canceling, you can. Because do you get 5 goes into both of those? 5 factors out, and you'd have negative 3 plus and minus 1 all over, and a 5 factors out of the bottom too. 5 times 2. That cancels that. Now, you did not have to do that, but it would be cool if you knew how to do that. Did anybody know how to do that and do that right? Awesome. Okay, then the last step is to actually get the answers. If you thought this was done, you're wrong. You cannot leave it that way. You're leaving me with a math problem. So Mr. Server, you should take negative 3 and add 1 and divide by 2, and then you should take negative 3 and subtract 1 and then divide by 2. You have to actually do that. So you have to actually give me the answer. What's negative 3 minus 1 makes negative 4 divided by 2?
Negative 2.
Yes. Yep. Negative 2 is one of your two answers. The other one is negative 3 plus 1, which makes negative 2, divided by 2? Negative 1. Your two answers were negative 2 and negative 1. Why would I have two answers to a quadratic? Because the parabola must have touched twice at negative 2 and negative 1. Good question. Yes, those are bald answers, they are called. I'm not supposed to leave them that way. So I should have said x equals this and x equals that. Thank you for bringing that up. If you wanted to write them in a point, absolutely. They are x-intercepts, so their y's are 0. So you could say negative 2 comma 0, and you could say 1 comma 0. That's a great way to write them too. All right, let's do another one like that. Here is your quadratic, and therefore, what's A? 1. What's B? 9. What's C? 10. Now, actually put it into the quadratic formula. And the way, once you get good at this, I think all of you are good enough now that you could handle this. It's x equals negative b, but do you really need to write out the whole formula? I think you could probably handle it doing it this way. Negative b, but I'm leaving an empty spot. Plus and minus square root of b squared, empty spot, squared. Minus 4ac, empty spot, all over 2 empty spot. And I know what those are, right? I know those are negative b at the beginning. And therefore, I can put in negative 9 right here. Plus or minus square root of b, which is 9, squared. 4a goes here, c goes here. All over 2a, and a is 1, so it goes there. And then I simplify it down, and I get the final answer right here, which is, let me think. 9 and 9 squared is 81, minus 40 is square root of 41. So negative 9 plus and minus the square root of 41. All over 2 times 1 is 2. Boom. Now, unless 41 can factor, and I think it's prime, isn't it? All right. So then I think we're done. If 41 had broken up, I'd have to be careful. Maybe I could simplify it more. I did 9 squared is 81. Would you agree with that? And then 4 times 10 is 40. 81 minus the 40. And that equaled 41. A lot of polite people in here. That's good. Okay, now decimal form, that just means you've got this answer already. Now, how could you make it a decimal? Use your calculator. And your calculator does not have a plus minus key on it. So you do it once with plus, and then you do it once with minus. And yes, your calculator is going to be allowed on the homework for today, so you may as well grab it, because I don't expect you to have it memorized what the square root of 41 is. I have no idea what it is. You know, the technology has moved from something you grab out of your bag to something you wear. Already they've got like things like watches, right? And what's the next step after that? Implantable. Implantable calculators, implantable. There's a person who has had an implant put in now to help him see color. He's colorblind. He has like a little implant. So now he can, through the little lens thing, it allows his brain to see color, and he couldn't see color before. So like for instance, he's looking at the light, and he can't tell if it's red or green. Wouldn't that be kind of annoying? Like if you're coming to a stoplight, kind of a big deal, right? But he's got an implant that just tells him through his brain, it allows his brain to see color, and it couldn't before. That's just one little thing. Did you know the world of technology is just exploding so fast right now? I know you're going to think I'm making this up, but they have just come up with a way to retrieve memories from rats and print them out. Because it's technology related to your brain. I was just talking about implants. They now can get, if they can get it from mouse, you can get it from a human. Can you imagine you could go in and have them print off your memories for you?
No, that's not good.
I know, that's insane. It's crazy. So yes, could you steal your memory? Could you abduct Steve Jobs and therefore print off all his memories and therefore know, okay, he's dead, but I know, somebody like that. And then print off all his memories and then know everything he was thinking about doing, all of his plans for his company? I know that's a long ways from now, but if they got the first image from a rat's memory, from its brain, that is a big deal, because that leads to human memories being possibly be able to be gotten. Lots of cool stuff coming. That's an interesting thought, yeah. A lot of people have donated their body to science, and you know, some people are like, no way, I don't want, you know, like some medical student like handling my heart later. Isn't that a weird thought?
15 if you wanted to get all your memories printed out. You can get 5,450 pictures of all your memories.
Where'd you get that from? What?
Like a memory for
Oh, a memory per day. Ooh, that's a weird idea. Yeah. But can you imagine how much that could help in solving crimes?
Yeah. So you
What if you could take the person who had just died and still get the memories out of their brain, and they could be able to tell based on time, oh my gosh, his last few memories were, you know, being attacked by his poodle. Oh, apparently the poodle did it. Anyway, okay. What was the square root of 41 anyway? What's the square root of 41? Needed some time to get your calculators out anyway. 6.4. So then you go through and say, oh wait, round to the nearest hundredth. That's not the nearest hundredth. That's the nearest tenth. 6.4 what? 0? Okay, good. Then I'm going to go through and go -9 plus 6.40 divided by 2, and you get a decimal. And then you're going to get -9 minus 6.4 divided by 2, and hit equals, and you get that answer. Do you have a calculator? All right, you want to borrow one? All right, give me some collateral. There's something wrong with this one. It's not equal to 0, so fix it. What's the easy thing I have to do? Add 4x. You could have divided by 4x, but by dividing by 4x would have left you a 1 on the right side, and that would have made it more complicated. Better to just add 4x to both sides, and you will have x squared plus 4x plus 2 equals 0. Yay, it's equal to 0. Now I know A, and I know B, and I know C, and you can do the quadratic formula, and it's easy from there.
Do you have to do both decimal forms?
Good question. It doesn't say which form to do, and if it doesn't say, you can default to leaving a square root in your answer. Only do the decimal form if it specifically says, must give answer as decimal, because it's a pain to have to grab your calculator and do that extra step. All right, I have a tip for you. I strongly recommend you always do b squared minus 4ac first, because don't you agree, at some point, you're going to have to do b squared minus 4ac. And if you do it early and you realize the answer comes out negative, you get to be done right then. See what I mean? That's why the determinant is good, because it can tell you when you don't even get an answer. So let's do the b squared minus 4ac part first. Don't have to do it this way. I'm just telling you, it's smart. B is 4, so I'm going to do 4 squared is 16 minus 4 times 1 times 2. And that's going to be 16 minus 8, which is 8. Now you might think, oh, well, so we wasted all that time. No, I know that the square root part is equal to 8. So now I can just do negative b, -4, plus and minus the square root of 8 all over 2a, which is 2 times 1 is 2. See, it didn't waste the time. I took what I did here and I put it here. And if it had come out negative, I could have just stopped right then, because discriminants that come out negative don't give you real answers. All right, so can I stop? No, because square root of 8 is not simplified all the way. Break it up for me. Square root of 4. Good, so final answer is, simplify that. 2 root 2, good. So now I can factor out the top. Factor it for me. Good, now what do you have left? Yep, all over 1 times 2 if you want to do it that way. Don't cancel the 2 yet. I think you're trying to cancel it already. There's still a 2 on the bottom. Now I can cancel it. Do you see the 2 2's I'm going to cancel? The 2 2's gone. And now I have that. -2 plus and minus the square root of 2. And I can't fix it anymore because I don't know what square root of 2 is. If they had said you must have a decimal answer, I would go through and figure out what the square root of 2 is and do it once with plus and do the problem once with a minus. All right, I think you get the idea. Let's jump right to the final. Actually, here's where you're home. Oh, wait. This is an interesting one, and it's important. We need to do this one problem together, because this separates the A's from the B's. If that's the solution, what was the question? Can anybody tell me what A or B or C is for sure? Yes. B's got to be -7. Done. I know B. How about A? A's got to be 2 because this had to be a 2 times 2, right? All over 2A. So that therefore it must have been a 2 for A. So A is 2, and now it gets to the hard part. Give you a hint. This is an equation. Something equals 65. What's the equation? B squared minus 4AC equals 65. And don't we know some of these? We do. We know A is 2. So this has got to be a 2. And we don't know C. But we do know B. B is -7. And now all of a sudden, I know I can just solve for C. It's just a little math problem that only has one variable in it. So it's 49 minus 4 times 2 times C equals 65. And then I go, I'm going to subtract 49 from both sides. -8C equals positive, 16. Well, I'm getting close. And C must equal 16 divided by -8, so it must equal -2 is correct. C was -2. So now what was the original quadratic? Y equals A was 2x squared. B is -7, -7x, and the C is -2. Holy cow, we did it. I'm going to give you another one that's like that. Yes. Yep. You do the opposite of whatever this is. All right. So then this next one, I don't even need you to solve it all the way. I just need you to get me the easy stuff. Let's say the equation is this. What's A? What's A? Would you agree that this is all over 2A and therefore A must be 1? Okay, good. A is 1. Okay, what's the B? B is -8. And then what's the little equation you could write? A was this, B was that, and then B squared minus 4AC. And we already know B, and we already know A will equal 45. Try to write me the right equation. Yes, it is square root of 45. My bad. No, wait. It's B squared minus 4AC. That's the thing under the root. So it's plain 45. Do you get this part right here came from B squared minus 4AC? So it's just plain 45. Okay, so then B, what was B again? -8. And -8 squared is 64. Minus 4 times A, what was A again? 1, good. Times C, there we go. And so you subtract 64 and you divide by -4 and you get a weird decimal, and that's okay. All right, I think you got the idea. Now, let's get to your homework. Your homework is just like what we just talked about there. It is using the quadratic formula, and the quadratic formula often comes out with 2 answers, but sometimes it only comes out with 1. What happens in that special time when it only comes out with 1 answer? It is the what? It's the vertex. And you can tell from the equation whether that vertex is a min or a max. If it came out of this equation, would the vertex have been a min or a max? Because this negative in front means it must be a parabola like this, right? So the vertex, wherever it is, must be a max. How do you know you got a vertex? Because you only got 1 answer. If you ever only get 1 answer, you found a vertex. If you get 2 answers, then they're just 2 spots that it touched. 2 x-intercepts. If it doesn't come up with any answers, it's because you came up with a negative under the square root, and that means that there were imaginary roots, and that means your parabola would have never touched. All right, now somebody must have this up on their screen by now so I can take a look at it and see which problems I want to eliminate. Let me take a look quick. Thank you. We're going to do that cut out the middle theme again, and 4, 5, and 6 are gone, and 11 and 13 are gone. 4, 5, 6, 11, and 13. I'm not giving you much time to work, it seems very reasonable. Remember, we graded homework today. I'm going to be grading it a lot. Keep getting it done. It's good for you. It really is. It'll keep you on track for one of the toughest tests you're going to have this whole semester is coming next. So this is not the time to skip your homework. It's not impossible. It's just probably one of the tougher ones. And that's all I have for you for today.